I'm studying today about the three processes is happening on the liver. The one is glycolysis, and the second one gluconeogenesis, and the third one is glycogenolysis. So first we will go to the glycolysis process. So glycolysis is the process where glucose breaks down to pyruvate in the blood stream. That means when we are eating, this will go to this channel, this carbon will go to the liver, and in there, in the liver side, there is seven spikes is there, that is called blue type 2 transponder. And the main job of this is to take the glucose inside, and at the same time it can take it out to the bloodstream also. So this glucose 2 transponder, once it brings into the liver, there is another process called there is another enzyme available in the liver, that is glucose 6 phosphatase. Because if this process is not done, this glucose will back to the bloodstream. So once it's came, the liver itself makes put one phosphate on this, and that process glucose 6 phosphate. Then again it goes to other subtraction like fructose 6 phosphate. And the next level goes to fructose 1,6 bis phosphate. So one phosphate on this, and on the 6th carbon another phosphate, and Bi means 2 and S means separate. Then the next process is going as glycerol aldehyde 3 phosphate, and in this side it is dihydroxytone phosphate, and that now this is only 3 carbons with 1 phosphate on either sides. Then the next stage is 1,3 by S phosphoglycerate, and in this side also same 1,3 bis phosphoglycerate, and next again it's going to the next level as 3 PG. PG means same phosphoglycerate. This side also something the same. Then it goes to 2 PG, and this side also same. It goes to 2 PG phosphoglycerate, and here it comes PEP, phosphoenol pyruvate. Then finally it goes to pyruvate, and then afterwards it goes to acetyl CoA, and that will go to the Krebs cycle and make ATP. So that is the first process. And the second one, we will see the gluconeogenesis. That means the breakdown of non-carb structure in fasting more than 6 hours. This process is mainly be used for the fat loss purpose, and in that case we have to do exercise like in order to start this process we need minimum 6 hours of fasting. So in that 6 hours of fasting, what happens is in our bloodstream the glucose will be already used, and then we have stored glucose in our liver, and also the same in the muscles also. In liver we have around 80 to 100 grams of 80 to 100 grams available there, and in muscle it is 250 to 400 grams glycogen. We have glycogen on muscles, and this process will start. As we said, after the exercise which is called HIT, high intensity interval training. After 6 hours fasting, we go to the high intensity interval training like 20 minutes. That 20 minutes, then another 3 minutes another 3 minutes for the muscles. So first we take the glycogen from the liver. That is from the hepatic cells. It is stored in a this form like polymer form. It is compressed and stored in the liver. And once this is finished, glycogenesis. But this process is finished, then the energy from the muscle is taken. Like that 200 to 250 to 400 grams it will take from the muscles. When it is in the case of these muscle does not have that glucose 6 phosphatase. So the muscle has to convert this into pyruvate and then it has to go to the liver. And in that section, there is a byproduct lactate and alanine, and these two are with the pyruvate will go to here and again it goes back to the bloodstream. For that, there is another process happening over here, that is the fatty acid break. Fatty acid break means triglycerol break. In triglycerol, we have 3 fatty acid and 1 glycerol bond. And this will go back to the liver with the help of glycerol kinds, and with the help of this glycerol adenylate, it will convert back and it will go back to the bloodstream and use energy.